Hello everybody, welcome to Guidancee Education Channel. We are continuing class 12 physics, chapter 2, electrostatic potential and capacitance. Under that we are discussing capacitors. I have already discussed the principle, shape and use of capacitors in the previous video. If you have not watched that, click the I button in order to watch that. In this video, we are going to discuss energy stored in the parallel plate capacitor. We will first discuss how energy is stored in the parallel plate capacitor. But before we start the class, watch the video completely so that you get all points clear. Please do not skip the video. If you think it is useful, do like the video. Do not forget to subscribe, share and leave your comments in the comment box below. Thank you very much. My name is Ananthavalli. Come, let us start the class. We have already seen that capacitors can store energy. Energy gets stored in the capacitor when it is charged. So we will first discuss charging of the capacitor. A parallel plate capacitor which is not initially charged, that is, its initial potential difference is zero, is connected to an external source of current, say a battery, through a switch. Suppose the battery has a voltage equal to V. Plate number 1, as you can see from the figure, is connected to the positive of the battery and plate number 2 is connected to the negative of the battery through the switch. When the circuit is closed, the battery pulls away negative charges, that is electrons, from plate number 1 and starts transferring it to plate number 2. As plate number 1 loses a certain number of electrons, say dq electrons, the plate develops dq positive charge. Initially, the two plates were neutral. The battery does work in order to shift the electrons from plate 1 to plate 2. This work done is stored in the capacitor as potential energy U. Each time the battery pulls away a certain number of charges equal to dq from the first plate and transfers that to plate 2. So, a charge equal to positive dq develops in the first plate. Number of charges removed from the first plate is equal to the number of charges deposited in the second plate. For the transfer of the first group of dq, no work is done because it automatically flows. As time proceeds, several such dq negative charges will be deposited on the second plate. For subsequent dq charges removed from the first plate, more and more energy, that is more and more work, will have to be done, because as positive charges increase on the first plate, the remaining electrons will be held tightly by the existing positive charges. Moreover, when the electrons are deposited in the second plate, there will be repulsion on the negative charges due to the already added electrons. Anyway, at each point of time, the first plate and the second plate develop equal number of positive and negative charges respectively. The charges reside only on the inner surface of the plates, that is, the surfaces that face each other and also face the space between the plates. Battery does work by spending its electrical energy. As time proceeds, the potential difference of the battery decreases. Charges on the positive and negative plates go on increasing. An electric field is set up between the two plates because of the potential difference between the two plates. The potential difference of the two plates is marked as small v. As the positively charged first plate has positive potential and the negatively charged second plate has negative potential, the direction of the electric field is from the positive to the negative, that is from the first plate to the second plate. As the charging proceeds, Charges get accumulated bit by bit, that is by several dqs, and each time the potential difference between the two plates increase, the electric field between the two plates also increase. At the same time, the electrical energy of the battery is getting used up, its potential is decreasing, and at a certain point the potential of the battery becomes equal to the potential difference between the two plates. That is, the capital V becomes equal to small v. At this point, maximum number of charges have been transferred and the battery cannot move further charges from plate 1 to plate 2. Charging is completed. The total charge on the two plates may be represented at this point of time as positive capital Q and negative capital Q on the positive and negative plates respectively. Total work done by the battery to shift total Q charge from plate number 1 to plate number 2 is stored as potential energy in the capacitor. Hope you have understood how the capacitor is charged. Remember, for the first dq charge transferred, no work is done. For the subsequent dq charges transferred, work is done because there is repulsion by the already transferred charges. Potential energy is stored in the space between the two plates, that is in the electric field. Remember this point also. If the video was useful, like the video, share the video with your friends and also leave your feedbacks as comments. Do not forget to subscribe to my channel if you have not yet already subscribed. Thank you very much for your support. We will meet in the next video with the derivation for calculating the potential energy stored in a parallel plate capacitor. Bye for the present. Take care.